Good morning, students. In this video, I am discussing about the complete chapter of the vectors. Okay. Definition: scalar. A scalar is a quantity which has magnitude but does not possess the direction. Okay. Which has only magnitude. Vector. A vector is a quantity which has both magnitude and direction. Both magnitude and direction also obeys vector laws of additions. Okay. Scalar only magnitude, vector magnitude and its direction also. Representation of a vector. A vector is represented by of a directed line segment AB bar or A bar, all denotes vectors. Okay. AB bar and A bar. Every vector has three main characteristics. First one, magnitude. The length of the vector AB or A is called the magnitude of AB. Therefore, it is denoted by mod AB or mod A. Okay. It is called the magnitude. Magnitude means the length of the vector of AB. Direction. The direction from A to B. Here you can observe A to B. It is called the initial point. It is called the terminal point. Initial point means where the vector starts. Here starts. Okay. It is the terminal point. Okay. Ending point. Support. The line of a infinite length of which the line segment is a part is called the support of the vector. You can observe this diagram. From A to B, it is called the support. Okay. Types of vectors. Okay. Zero vector. A vector whose initial and terminal points are coincident is called the zero or null vector. Unit vector. A vector whose magnitude is unity. Magnitude is unity is called a unit vector. It is represented by A cap, that is equal to A bar by mod A bar. A bar by mod A denotes the unit vector. Like and unlike vectors. Here you can observe these are the same direction. Two vectors having same direction is called the like vectors. Same direction. Unlike vectors, opposite direction. You can observe these two opposite directions. Collinear vectors. Vectors which are parallel to each other or anti-parallel and having same initial points are called the collinear points. Vectors which are parallel to each other or anti-parallel and having same initial or final points are called the collinear points. Co-initial vectors. Vectors having same initial point. You can observe this is the same initial point same. Okay. Free vector. Vectors whose initial point is not specified are called the free vectors. Here you can observe the initial point is specified here in co-initial. In free vector there is not mentioned. Localized vector. A vector which is drawn parallel to a given vector through a specified point in space is called the localized vector. Equal vectors. Two vectors are equal if they have same magnitude, that is equal to AB bar is equal to CD bar and same direction. AB bar by mod AB is equal to CD bar by mod CD. Okay. Equal means same magnitude and same direction. Addition of vectors. Triangle of addition. You can observe this diagram. A to B, A, B to C, B. Then AB plus BC is equal to A plus B, that is equal to AC. It is called the triangle of addition. Parallelogram law of addition. OA plus OB is equal to A plus B, that is equal to OC. Properties of vector addition. A plus B is equal to B plus A plus B plus C is equal to A plus B plus C, A plus 0 is equal to A minus A plus minus A is equal to 0, K1 plus K2 into A is equal to K1A plus K2A. Section formula. You know that this is the very simple formula, internal division. This is the point P. M. In geometry already we discussed about this formula, mx2 plus nx1 by m plus n, my2 plus ny1 by m plus n, same like this. C bar is equal to ma bar plus nb bar by m plus n. External division, ma bar minus nb bar by m minus n. Coplanar vectors. Vectors are said to be coplanar if all them lie in a same plane. All them lie in a same plane. component of vectors in 2 dimensions. Here you can observe this is the x, this is the y, this is the OA. That is equal to OA is equal to root over x square plus y square. Here given OA is equal to xi plus yj. Therefore, mod OA bar is equal to root over x square plus y square. Here given this is the point O, this is the x, this is the y. Therefore, AB is equal to OB minus OA, that is equal to x2 minus x1 into I plus y2 minus y1 into j. Component of vector in 3 dimensions. Here you can observe that is this is the x, y and z, this is the OP. OP is equal to mod OP is equal to root over x square plus y square plus z square. Linear combination of vectors. A vector R is said to be a linear combination of vector a bar, b bar, c bar if there exist scalars x, y, z such that R bar is equal to x a bar plus y b bar plus z c bar. Okay. Collinearity of 2 vectors. If 2 vectors are collinear, then the condition a bar is equal to lambda into b bar, for second one x a bar plus y b bar equal to 0. Collinearity of 3 points. 3 points with position vectors a bar, b bar, c bar are collinear, then x a bar plus y b bar plus z c bar equal to 0. 3 points a b c are collinear. Any 2 vectors a b comma b c comma c a are parallel. A b bar is equal to a1 I plus a2 j plus a3 k. B c bar is equal to b1 I plus b2 j plus b3 k are parallel. Then the condition is a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Linear combination of vectors. Given a finite set of vectors a bar, b bar, c bar, then the vector r bar is equal to x a bar plus y b bar plus z c bar so on is called a linear combination of a bar, b bar, c bar for any x comma y comma z belongs to R. You can observe this. R bar is equal to x bar, x into a bar plus y into b bar plus z into c bar. Linear independent. If x1 bar, x2 bar, x3 bar, so on xn bar are n non-zero vectors and k1 comma k2 comma k3 so on kn are n scalars. If the linear combination of k1 into x1 bar plus k2 into x2 bar plus k3 into x3 bar so on kn into xn bar equal to 0. Okay. Here k1 equal to 0, k2 equal to 0, kn equal to 0, then the vectors x1 bar, x2 bar, xn bar are linear independent vectors. Linear dependent. k1 x1, k2 x2, k3 x3 so on kn xn bar equal to 0 if there exists at least one of kr not equal to 0, at least one of kr not equal to 0, then x1 bar, x2 bar, x3 bar so on xn bar are said to be linear dependent. Note, 2 non-collinear vectors are always linear independent. 3 non-coplanar vectors are linear independent. More than 3 vectors is always linearly dependent. Okay. Product of 2 vectors. There are 2 types. The first one dot product, the second one cross product. Dot product. Dot product. You can observe this diagram. OA is equal to A bar, OB is equal to B bar. Theta lies in the A and B, OA and OB. A dot B is equal to mod A bar, mod B bar cos theta. That is equal to AB cos theta. Note, if A and B are perpendicular, then theta is equal to 90. Therefore, A dot B is equal to 0. If A and B are like vectors, theta is equal to 0. That implies A dot B is equal to mod A mod B, that is equal to AB. If A and B are unlike vectors, you can observe A and B are like vectors, theta is equal to 0. A and B are unlike vectors, theta is equal to pi. Therefore, A dot B is equal to minus A dot B. I dot I is equal to J dot J is equal to K dot K is equal to 1. I dot I is equal to J dot J is equal to K dot K is equal to 1. I dot J equal to J dot K equal to K dot I equal to 0 means I dot J equal to 0, J dot K equal to 0, K dot I equal to 0. Scalar product in terms of the components. A is equal to A1I plus A2J plus A3K. Then A dot B is equal to A1B1 plus A2B2 plus A3B3. angle between two vectors. If A and B two vectors and theta b is the angle between them, then cos theta is equal to A dot B by mod A mod B. A dot B by mod A mod B. If A is equal to A1I plus A2J plus A3K, B is equal to B1I plus B2J plus B3K, then cos theta is equal to A1B1 plus A2B2 plus A3B3 by root over A1 square plus B1 square plus C1 square, root over A2 square plus B2 square plus C2 square. Projection and component of a vector. You can observe this diagram. OA is equal to A bar, OB is equal to B bar, and theta is equal to angle between OA and OB. Projection of A on B. Projection of A on B. A dot B by mod B bar. Projection of B on A. A dot B by mod A bar. Component of B along A, that is equal to, you can observe this is the OM. This is the OM. A dot B by mod A square dot A. Component of B perpendicular to A, that is equal to MB. MB, this is the. Therefore, formula B minus A dot B by mod A square dot A. Vector product or cross product. A cross B is equal to mod A mod B sin theta n cap. You can observe this diagram. OA is equal to A and OB is equal to B. This is the n, that is equal to A cross B. Where n cap is a unit vector perpendicular to both A and B, such that A bar, B bar and n cap from a right-handed system. The properties. A cross B is equal to mod A mod B sin theta. A cross A bar is equal to 0. I dot I cross I, J cross J, K cross K equal to 0. You can observe that I cross J, that is equal to K. J cross K, that is equal to I. K cross I, that is equal to J. A is equal to A1I plus A2J plus A3K. B is equal to B1I plus B2J plus B3K. A cross B, I, J, K, A1, A2, A3, B1, B2, B3 in that. Area of triangle. Area of triangle, you can observe this diagram. Half A cross B. If A comma B comma C are the position vectors of three vectors of triangle ABC, then its area half into A cross B plus B cross C plus C cross A. Area of parallelogram. If A and B are adjacent sides of a parallelogram, you can observe this diagram. This is the A, this is the B. Then area A cross B in modulus. If A and B are represents two diagonals of a parallelogram, these are diagonals, then its area half mod A cross B. Scalar triple product. A cross B dot C is equal to box ABC. Box ABC. Box ABC. A is equal to A1I plus A2J plus A3K. B is equal to B1I plus B2J plus B3K. C is equal to C1I plus C2J plus C3K. Therefore, A cross B dot C is equal to det A1 A2 A3, B1 B2 B3 and C1 C2 C3. Okay. All you know the formula of det. And this properties. A cross B dot C is equal to A dot B cross C. Box ABC equal to box BCA is equal to box CAB. Box ABC is equal to minus box BAC. Box KABC is equal to K box ABC. In box there are two values are equal. Therefore, box AAB, that is equal to answer is 0. Three non-zero vectors ABC are coplanar, then box of ABC equal to 0. Scalar product of four vectors A cross B dot C cross D, that is equal to modulus A dot C, B dot C, A dot D, B dot D. Volume of parallelepiped. You can observe this diagram. If quaternary edges of a parallelogram are A comma B comma C, then its volume is box ABC. Box ABC. This is the value O. Volume of tetrahedron. If A comma B comma C comma D are the position vectors of ABCD of a tetrahedron ABCD, then its volume is 1 by 6 AB bar AC bar in AD bar in box. Okay, 1 by 6 box AB bar AC bar AD bar, or 1 by 6 B minus A C minus A D minus A in box. If A comma B comma C are the position vectors of vertices A comma B comma C with respect to O, then the volume of tetrahedron OABC equal to 1 by 6 box ABC. Vector triple product. The vector triple product of three vectors A, B, C is defined as the vector product of two vectors A and B cross C. It is denoted by A cross B cross C. You can observe these two formulas. A cross B cross C is equal to A dot C B minus A dot B C. B cross C cross A is equal to B dot A C minus C dot A B. Okay, you can observe these two formulas are very important. The direction of A cross B cross C is perpendicular to A and parallel to B and C. Reciprocal system of vectors. If A comma B comma C be any three non-coplanar vectors such that box ABC not equal to 0, then the three vectors A dash B dash C dash define the equation. A dash is equal to B cross C by box ABC, B dash is equal to C cross A by box ABC, C dash is equal to A cross B by box ABC, or called the reciprocal system. These are called the reciprocal system. Properties of reciprocal system. A dash is equal to BB dash is equal to CC dash is equal to 1 means A dash is equal to 1, BB dash is equal to 1, CC dash is equal to 1. Box ABC, box A dash B dash C dash is equal to 1. A into B dash is equal to 0, A into C dash is equal to 0. B into A dash is equal to 0, B into C dash is equal to 0. C into A dash is equal to 0, C into B dash is equal to 0. These are the very important formulas. You can observe and you can check the formulas. These formulas are very important for your JEE mains examination. All the best. Thank you for watching. Like, share and subscribe. All the best.